All right, we're actually going to continue our discussion of kinematics, distinguishing between two special quantities in physics called vectors and scalars. And you're going to hear those terms, but it turns out there are certain things that we measure in physics that are vectors and others are scalars. Those are just the names. Here's what they mean. Some things have a size and a direction. Some things only have a size. And we're going to distinguish between distance versus displacement, distance being a scalar, displacement being a vector. Speed versus velocity, where speed is a scalar and velocity is a vector. And then we're going to actually tighten up our definitions of vector versus scalar in this video. So we're just going to go ahead and talk about a couple of the ideas, and you'll take some notes, and then we'll come back in class, clear up some misconceptions, and work some problems. All right, so this is the first lecture of week 2, and we've got some new vocabulary words to cover, so it's kind of important that we get into that right now and kind of talk a little bit about what's going on. So with that in mind, let's get started. So one of the first concepts we want to cover is this thing called distance and displacement, and I'm actually going to start by defining displacement, and the way we're going to define it is like this. So suppose I have a starting point, say here, and I'll call that x naught. Okay, so we'll say here's my origin, let's say, and I have an object that's sitting at x naught, and then it, say, I don't know, we'll make it an ant. So we'll make this little ant. This is a really bad drawing of an ant, I know. And it goes all the way around, and then it winds up at some final position that I will call x final. Now, here's the weird thing about this. The displacement is defined as your final position minus your starting position, which is a really weird thing to say. Okay, that's the definition of displacement, and it's something you kind of have to memorize. Okay, so in other words, I start here, I go all the way around, and I wind up here. Okay, that's displacement. Is you take this coordinate, you subtract off this coordinate, and that's it. Okay. The other factor of displacement we have to take into account is that we actually talk about the direction that it goes in. So what I mean is this. I started off here, and I wound up here. So if I were to kind of draw like a compass, this is north, west, south, and east, what I would say is I actually wound up east. So I would say my direction in this case would be east in this particular example. And that's something very important about displacement. It's not only a number, it also has a direction. So I want to put that out there. So in fact, I'm just going to say it. So displacement is a number with a direction. Okay. Now the other definition I want to talk about is this thing called distance. Okay, it's slightly different from displacement. The way we define distance is it's the actual length of the path you travel. So in other words, distance is this whole path all along here. You get out a ruler, or a piece of string, and you go all the way around the path, measuring it as you go along. And then whatever the length of that string is that you lay down during that whole path, that's the distance that you travel. And the thing about distance is it has no direction. Okay? That's our first kind of concept. Okay? And I'm doing it briefly in the video because we're going to talk about it more in class. Second idea, speed versus velocity. So speed is very simple to define once you have distance. Speed is your distance traveled over the time that passes. Okay? And we're going to contrast that with the idea of velocity. When you want to calculate velocity, what you do is you actually take your displacement, your x final minus your x initial, and divide it by the time that passes as you travel. Okay, so that is the second definition of the day. And finally, I want to contrast this with the third definition that we need to look at. The definition is vector versus scalar. Okay. Vector, okay, is actually really important. And I want to say one more thing about velocity. The direction of your velocity is in fact the exact direction of your displacement. So in this example that we started off with, we would say the velocity is due east. Okay? So whereas speed is simply your distance over the time, and it has no direction. So we have these quantities that have both a size and a direction, and we call those vectors. So a vector is a quantity that has a size and a direction. And there's a big word that we use for size, and it's called magnitude. That is a 3-syllable word that means size. And then we have quantities that have only magnitude or only size, and we call those scalars. So if it's only magnitude, it's a scalar. If it's magnitude and direction, that's a vector. And so those are kind of the basic ideas we'll be working with. All right, so let's actually look at an example. This is sort of the classic example that we like to use in physics, which is, this whole idea of some kind of object on a circle. So we've got this object, and we'll say that we start off here, and let's say that we go all the way around the circle like this. So in other words, we start off as our initial position here, and then it actually turns out that our final position is the same as our initial position. And the question we ask is, what is the displacement? And to make this more obnoxious, let's say that this is a circle, and we'll give it a radius of 3 meters. Okay. So if we ask what the displacement is in this case, if we go all the way around, the answer is we have x final minus our x initial. The answer is, since we started and ended in the same place, our displacement's 0. It's a weird definition, just go with it. Okay, I'm just giving you this definition. I know it's weird. We use it a little bit in physics. We don't use it too much, and actually we're not going to cover it too much after this particular unit, so I wouldn't worry about it too much. Now, the other question we ask is, what distance did we cover if we go all the way around? And the answer there is, well, we're going one circumference. So what we can actually say is the distance is 2 times pi times the radius. When we actually calculate that, that ends up being like 6.28 times 3. So 18.84 meters. That's the actual distance that we traveled. Okay. So that's the basic idea. That's just an example to sort of explain it. Now, an interesting way to do this is, I'll actually do this, we'll see if we can try this approach. Suppose we start here, and in fact, instead of ending where I said we ended before, let's say that we end halfway around the circle. So a really good question to ask is, now what is the displacement if we go half around? So we know that x final minus x, so halfway around. If we go halfway around, we have x final minus x initial. And, well, we go 3 meters and another 3 meters. So that ends up being 6 minus 0. Okay. So we have a displacement of 6 meters. And if we ask what direction that is, we would say it's west. So we wound up 6 meters west from where we started. Now, if we look at the distance, the total distance we traveled, why, that's going to be half a circumference, which is pi r, which ends up being then 9.42 meters of distance covered. So that's a really good way to kind of contrast distance and displacement. Now, let's take this one step further. Suppose I tell you that each of these trips we accomplish in 4 seconds. So we'll say that we go